Lesson 4, Lewis dot diagrams for ionic compounds. So to do the Lewis dot diagrams, you'll need to draw the ion dot diagrams next to each other, making sure that 1, the ion charges cancel out, or in other words, they add up to 0, and 2, the opposite charged ions are next to each other, and the like charged ions are far away from each other as they can possibly be. So to show you some illustrations I think will help you understand what those two things mean. So if we happen to have sodium chloride, and we drew the dot diagram for sodium chloride, sodium likes to give away its one valence electron to chlorine. Therefore, you got rid of one negative electron, causing it to become positive. Chlorine now has one extra electron, so it is negative. So remember, the sum of the charges must equal 0. So I have one plus ion and one negative ion, and when you add those two together, you get 0. Now let's look at one that isn't as straightforward. So we have calcium chloride, CaCl2, and you'll notice that calcium gave away 2 electrons, one to one chlorine ion and another to the other chlorine ion. And you'll notice that they are written far apart from each other. Both chlorines are not near each other. They're as far apart as they can be, but still next to calcium. So we have 1 2 plus ion plus 2 negative ions equaling 0. So really you need to think about this negative should be here with this 1. And so we would have 2 negative 1 ions that would then cancel out the plus 2 ion. So let's practice and draw the dot diagram of the compound containing barium and sulfur. And barium is a plus 2 ion, so it has given away 2 electrons, and it has given those here to sulfur, so therefore now sulfur has 2 more electrons, giving it a 2 negative charge. Now we have 1 barium ion with a plus charge, adding to 1 sulfur ion with a negative 1 charge, and you do get a charge of 0. So let's draw the dot diagram of a compound containing aluminum and bromine. Aluminum has a 3 plus charge because it likes to get rid of 3 electrons, and to add the bromines, we would add them around the aluminum atom. And each bromine is a negative 1 charge because each one got one of the electrons aluminum was giving away. So to look at the charges, we have 1 plus 3 ion, that's my aluminum, plus 3 negative 1 ions. So here's 1, 2, 3, and since they're each negative 1, this ends up becoming negative 3. So a plus 3 plus a minus 3 does give me 0. So draw the dot diagram of a compound containing barium and chlorine. Well, we bring barium in, and barium tends to have a plus 2 charge. It gives 1 electron to chlorine over here and 1 electron to chlorine over here. The chlorines are as far apart as they can be. And here we've got our barium ion with the plus 2. And we have 2 negative 1 ions, and we add all of this up, we do get 0. So how about the dot diagram for a compound of magnesium and bromine? It will be identical. Magnesium here in the middle with the plus 2, bromines on either end with their negative 1. So let's check our understanding. Draw the dot diagram of a compound containing magnesium and chlorine. Well, magnesium is a plus 2 ion, and we would have a chlorine on either side, which would both be a negative 1 ion. And if we would take the 2 plus of the magnesium, add that to the 2 times negative 1, 1 for each of the chlorines, we would actually end up with a 0. So you would actually end up with Mg and 2 Cls.